So we're beginning our first video in the calculus section of Learn Biology. So in the Thinkwell interface online on www.thinkwell.com, we're going to start with an introduction to derivatives. And we're going to go to 3.1.1, rates of change, secants, and tangents. And where everyone has different order of problems, so I'm just going to go by the problems I have. So we're going to go to problem 2, and we'll go to this. So my problem 2 here states, find the equation of the secant line to the curve f of x equals 2x squared minus 3 on the interval 1 to 1.2. So beginning, our step 1 will be, if we go to step 1, we have the points 1 and 1.2. So this is x1 and this is x2. And we have to find the y values. To find the y values, we're going to simply plug in 1 into 2x squared minus 3. So we'll have 1 squared minus 3, and this gives us -1. So we have 1, -1, and then we'll do 2 and then 1.2 squared minus 3, and this will give us -0.12. So we have our points -0.12. So this is y1 and this is y2. Our next step, we're looking for the equation of the secant line, which is the slope. We need a slope, so we have m, which is a slope, and the equation for slope is y2 minus y1 over x2 minus x1. So if we solve this out, so we have -0.12 minus -1 over 0.2, we will get 4.4. So that is our slope, m. Step 3, we have to find our y-intercept. We're going to start with point-slope form. Point-slope. And point-slope form is y minus y1 equals m with x minus x1. So in order to do this, we're going to pick a y point and an x point. So what we will do is pick the easiest one, which would be 1 and -1. This would be the best option to put into the point slope form. It will make our job easier, but don't get me wrong, you can pick any point that you want, but this is the easiest one. So we'll extend the page here some. So we have y minus 1 equals 4.4 x minus 1. And here, this is y minus -1, so we can just make that a +1. And then we simply move the y over. So we have y plus 1 equals 4.4x minus 4.4. And we're going to subtract 1. So -1 and -1. So we're going to be left finally with the equation y equals 4.4x minus 5.4. And this right here is our solution to the problem. Alright, so moving on to another problem. I can go back to this. And as you can see, that was the correct answer. We will go to this problem. Alright, so Mary is competing in the 100-meter dash. Suppose that her position is described by the position function pt, where t is the time in seconds and pt is her position in meters. If she finishes the race 100 meters in 15 seconds, and her instantaneous velocity at t equals 1.5 seconds is 6.2 meters per second, what is the slope of the line tangent to the graph of pt at t equals 1.5? So basically the main parts of this are as follows. We have this information here that at t equals 1.5 seconds, her velocity is 6.2 meters per second. And what we're looking for is the slope of the line tangent to the graph of pt at 1.5. Basically, we have a graph here. We have position and we have time. Okay, and this is pt. Her graph might look something like this. This is 100 meters. And we know she's done in 15 seconds. Her graph might look like this. She might speed up, slow down, speed up. But we know that at 100 meters, at 15 seconds, she's done. We're asked that what is the line tangent to the graph of pt at 1.5? So we have 1.5 seconds somewhere here. We can say right here, 1.5 seconds. What we're looking for is that at some random point, what is her speed? Okay, so there's a straight line here, so what is her speed? But the thing is that they've given us the speed. It's 6.2 meters per second. So that is the answer. 6.2 meters per second, because it is given to us. The key to this is to remember that the derivative of position, so the derivative of position is velocity. The line tangent is always velocity. So if they're giving a speed is a line tangent. That is the main concept here. Velocity is the line tangent. Velocity is the slope. It is the slope. And that's the main thing to remember. Alright, so moving on to another problem. You can go back here. An ant is crawling across the driveway. Its position is described by the position function pt equals 1/5 t plus 2, where t is in seconds and pt is in feet. What is the ant's instantaneous velocity at t equals 1? So this again is a very, very simple problem. We just said that velocity equals line tangent and slope. We're asked for the instantaneous velocity at t equals 1. So velocity and slope are equal. So we basically look at this equation and we see that the slope is 1/5. It's 1/5. And that is the answer. 1/5. So knowing that, we move on to the next problem. And we'll just open a new page here. Alright, so another problem. The following graph is given, and we are asked of what can we say about the instantaneous velocity of the object at t equals 3. So as it is shown here, they've pointed it out. Instantaneous velocity. What is the slope? Again, what is the slope at time 3, at t equals 3? That is our solution. That's what we need to find. So if we go through this graph here, at 3 we see that our line tangent is horizontal. And horizontal lines always have a slope of 0. So 0 slope. So what can we say about instantaneous velocity of the object? So if we have a 0 slope, we can say that the object is not moving. So at t equals 3, the object is not moving. And that's the answer to the problem. Now we'll do our final problem, which I believe is the hardest one in the chapter, in the question set. And that is this problem here. Alright, so a biker rides along a horizontal straight line with its location given by the function st equals 1/10 t squared, where t is measured in minutes and s is in miles. To estimate the instantaneous velocity at time t equals 2 minutes, compute the average rate of change from t equals 1.9 to 2 minutes. So what we're looking for is average rate of change from 1.9 to 2. Average rate of change. So average rate of change equals change in position over change in time. We're given our change in time already. So we know that the bottom change in time is simply 2 minus 1.9. So that is our change in time. That's delta t. Our top numerator, we don't have a position. We have a position function, but we don't have the positions. So we will have to calculate that by hand. So basically, we're going to plug in the points 2 and 1.9 into this equation here. So we're going to do 1/10 times 2 squared. So that takes care of this 2 right here. Then we're going to do minus 1/10, because this is change in position. Change in position. So we're going to do 1/10 and then 1.9 squared. So that is our change in position. And when we do all of this, we're going to get 0.039 divided by 0.1. And this gives us 0.39. And that is our answer right there.